dinner. I was hoping that some of your dinner conversation might be about interesting technical questions to throw at these engineers. Before we get get them ready, and if you haven't thought of any yet, think of them. What we're going to do first of all, though, is just have people introduce each other. I know that you probably recognize some of the faces and the names from yesterday, but we'll first of all go through and we'll get these guys to introduce themselves, where they work from, and what part of Lustre they're responsible for. And let's start with Nikita.
Hello, I'm Nikita Danilov. I work from Moscow, Russia, and I work with some little bits here and there on metadata server, and currently I work mostly on client I/O and some other bits also.
Hi, I'm Andreas Dilger. I work from Calgary, Canada, and I have my hands in lots of areas, but these days I mostly, don't actually do real work. I do product quality management and releases and things, mostly on the production side rather than in the fancy, crazy stuff that's going on elsewhere.
Hi, I'm Wang and I work for Lustre Group for about 5 years. And I mean, in the first 3 years, I work on CMD, those stuff, and then I fix bug about 1 year. Then currently I work in Tennessee Oak Ridge National Laboratory, and I'm focused on the scientific application I/O performance right now.
I'm Isaac. I work from Knoxville, Tennessee, and I've been working exclusively on the Lustre networking subsystem.
I'm Robert, and once a long time ago I wrote LConf, so sorry about that. And I recently rejoined the Lustre team last month, and looks like I'll be working on recovery again, and kind of an overview of just reliability and recovery issues. Oh, and I work from Sunnyvale, and here in the Bay Area.
Hi, I'm Ricardo. I work from Lisbon, Portugal, and I work on making ZFS work well with Lustre, or at least try.
Hello, I'm Vitaly Fertman. I work from St. Petersburg, Russia, and I work mostly on different metadata optimizations and LDLM optimizations.
I'm Oleg Drokin. I work from Knoxville, Tennessee, and my hands are also in lots of places, mostly fighting fires and production releases, also metadata improvements, locking improvements, exporting Lustre with NFS, this sort of things.
Okay, so we have only 2 microphones today, and we're going to have to share them. I'm happy to hand these right over to the engineers in just a moment. So, who would like to pose the first question to this group of engineers? Who's got a question? Yes.
Hi, Adam Monroe, SharkNet. I was wondering if you guys look at different file systems like glustrefs or SILF or Ceph, and in terms of evaluating, comparing, and maybe looking at some of the things that are good there and putting them into Lustre, or if you look at these things at all. So.
Trying to get somebody else to answer a question.
I do not recall.
I follow Linux FSDevel, and I see some of the high level issues that are coming up with these file systems. I don't honestly have time to dig into a lot of the different ones, but I do pay attention to the kind of architecture that they're looking at. Lustre FS and Ceph, you know, I do see if they're, you know, coming up with some great ideas that, you know, we want to look into, you know, replication, if they have great ideas on how to do that. You know, to be honest, some of those file systems are structured in a lot of ways similar to Lustre. I mean, it's a file system on top of a file system. I think a lot of the newer ones, you know, they've made the same decision that we made years ago, which is we don't necessarily want to develop a disk file system of our own, because that in itself is years and years of effort. And so they're taking different approaches of, you know, filtering the access to backing file systems. But so far, you know, those projects themselves are relatively new, and I think they'll find that while it's easy to make a you know, a working system that, you know, handles the, you know, it works well under normal conditions. The hardest part that we always have, I mean, as you see with size on MDS or something like that, you know, it's easy to just say, well, store the size on the MDS, you're done, right? But the hardest part, you know, comes when you have these, you know, 7 servers failing in different orders and things like that. And they will also find that, you know, their simple solution gets increasingly complex as they, you know, encounter real-world problems.
Maybe just to build on that question a little bit, I'd like maybe Nikita can comment on how some of the influence of the work that some of our engineers or some of our engineers did, for example, on Riser FS, have influenced work on our own file system.
Well, actually, surprisingly, Riser FS was never seriously considered as a backend for Lustre. But of course, some ideas influenced new features indirectly. And there is also a lot of convergence in this space going with other projects. For example, BTFS from Oracle now. It's very similar to Riser FS, and they have a distributed file system built on top of it. OCFS, I think. No. Sorry, I forgot the name. And it has some features very similar to what we are currently doing. Yes, right. Actually, yes, it's developed by persons that used to work for CFS. So there is a lot of communication going indirectly in this area.
Also, when you're driving really, really fast down the highway, you don't sometimes have a lot of time to look in the rearview mirror. So, other questions? Who's next?
Hi. So, Andreas, yesterday you described the CMD, and you said that when you start out, all the files would be on one MDS, but then if it got to be huge, you'd split it to multiple MDS. So then you said they might run into certain problems, like if something failed. Then you know, while you're splitting or things like that, you're passing the mic already. My question is, why not just start striping on all MDSs right away?
Actually, yes, this probably, as a hindsight, that should have been a approach. It's right approach, because the splitting directory initially at the time of creation is much simpler than splitting it dynamically. But the concern was that this will consume too much space, and specifically too much inodes. Because if you have a lot of MDS and if you create a directory and it's immediately split across all servers, and you consume an inode on every server, and you consume at least 8 or 4 kilobytes of space on every MDS.
There's also the issue that comes up with why don't we widely stripe files on every OST? And it's the same issue as well, is that if you're striping your directory on every MDS all the time, then you have to contact every MDS when you're doing a read dir or a stat or something like that, because the data itself is going to be distributed as well. And you can start doing things like size of directories on MDS 0 or something like that, but it also means that you're involving all of the MDSs in every directory operation. So we do it the same way. That's not currently possible, but it's definitely something that we'll want to do.
Anyone else want to comment on the panel? No. Okay, another question. Next question.
I was wondering on the ZFS work that's being done, or the studies that have been done so far, if anyone's looked at time-space trade-offs, because ZFS natively allows four essential options. On the high end, it's SHA 256. There are two other checksum algorithms. I don't recall off the top of my head what they are. And then obviously you can turn checksumming off. So what is the space-time comparisons between the algorithms in use and the possibility of collisions on extremely large file systems? So we have a good feel for that or not?
I'm sorry, I didn't quite understand the question. Could you just repeat that?
So,
please?
like, it takes a certain amount of time with SHA 256 to checksum each block within ZFS, and it also takes having checksums enabled. Putting checksum data on the disk is going to take a certain amount of space. So I was just wondering, of the three algorithms that are available in ZFS, if anyone's done a comparison between how much effort's required for each one of these algorithms time-wise, how much additional space might be used within the file system, and what that might mean for really large file systems where you have petabytes and petabytes of data.
Okay, so the checksums don't occupy any space because the checksums are stored on the block pointers, and each block pointer already has space to store the checksum. So even if you disable checksums, the space that you use is exactly the same, right? And as far as performance, the default checksum in ZFS, from the benchmarks that I did, I noticed that it can do about one core in a thumper can do about 1 gigabyte a second of checksumming. And I also noticed that, for example, the SHA 256, it's much heavier. I don't know exactly how much the performance cost is it? But I would say that typically most users would want to use the default checksum that ZFS provides. And also, I don't know if you remember, but in my presentation, I tried disabling checksums to see how much improved performance it had. And for that specific benchmark, which was basically RAID 0 write throughput, there was absolutely no difference in the throughput because well, at least that was the result. So I don't know if that answers your question.
Andreas, anyone else want to comment? No? Okay. Next question.
Hi. I have a small cluster that has its InfiniBand, and the main use of the file system is over InfiniBand, but the servers also have Ethernet connections, and I'm looking at connecting up additional clients over Ethernet to the servers, for instance, for visualization usage or other usage. And I'm wondering if there are tools for managing, client access, basically. In NFS, you can export the file system and you can control who's allowed to mount it. And in Lustre, you don't have that. Is that something that's possible or under consideration?
Actually, we have a feature already available that's called root squash, kind of like in NFS. So it doesn't allow you so big access, but at least you can define that all of the clients except this one, the root user is mapped to this other user. And in upcoming, sorry? Yeah, it's already existing, so you should be able to use it. in a real soon now being released 165. And then, of course, for upcoming versions, we are going to have those Kerberos and so on, where you will have much more fine-grained control.
In addition to that, I mean, one technique that some people use is doing the IP, well, I can't remember what it's called anymore, IP filter, IP tables. It changes every kernel. And so IP tables you can use to block access. Livermore also has a patch that isn't up to snuff according to Eric, so it hasn't gone into LNet yet. But the mechanism for essentially hosts.allow based on IP addresses, right? And so that lives inside Lustre, and the LNet acceptor will just deny connections based on IP address, right? The reason it hasn't gone into LNet proper is because with some of the address spaces for IPv6 and other network types with subnets, like with the Lustre networks, the address space becomes so big that you can't just have a straightforward lookup table to do it. And so Eric wants it to be some sort of tree implementation internally, so that you can efficiently, like routing, you can efficiently determine whether this host should be allowed or disallowed, instead of walking over a giant table that iterates every IP address that's acceptable.
Okay, anyone else? Next question. Mark.
We hear a lot about MDS performance improvements. I heard at least 3 people, I think, say that they had some MDS relationship. I've heard that MDS are limited by CPU, that putting in a flash device would or wouldn't help. I've heard different opinions on that. Now, I'm wondering if someone would like to talk about what the true limitations to MDS performance are today. Maybe what is the approaches being used to address those, and make a comment on whether when we go to ZFS, how things change in this regard as well.
I cannot comment on ZFS much, so somebody else will. But the biggest limitation with MDS right now is that you need to speak to it all the time from clients. This is the biggest performance impact. So upcoming metadata cache, write-back cache, that's what will bring in the huge performance boost. Aside from that, the disk limitation is real, and the limitation is of the seek latency. So one might think you will have a huge boost of performance when you will use something like Flash. But for many people that didn't realize, because they already use some smart controllers that have gigabytes and gigabytes of cache. For example, at Oak Ridge, there were some tests where you do metadata heavy workloads, and until certain points, there is no difference between flash and disk because of that cache. But once you go fill in the controller, then you start to see a sharp drop-off in the disk performance because of all of the seeking. And metadata is, of course, nothing like reading gigabytes of data continuously. Also, since it's so bad on RPCs, we are trying to cut those RPCs. For example, Vitaly did this nice feature when we are able to cancel locks preemptively, when we know that we will cancel them, cutting sometimes the latency several times when you do MDS stuff. And I hope somebody can comment on ZFS now.
As far as ZFS goes, well, we don't have the user space MDS. I'm not sure if we have it working yet. We don't, right? So we haven't even done any benchmarks. And for me, it's hard to predict performance because my Lustre knowledge is also a bit limited. Perhaps Andreas could comment on that.
I think Ricardo is right. We don't know exactly with ZFS I mean, there are some benefits with ZFS in the sense of the it's a waffle type layout right anywhere. So any new metadata operations will result in linear writes, because everything's getting reallocated every time, and so that has the potential for speeding things up. But at the same time, a lot of optimizations that we've done to LDiskFS have been to try and work in that area as well. Like we don't read any inode tables. We allocate the inodes sequentially for new and files in the same directory, and so there's a potential for ZFS speeding these things up. We're not totally sure yet. The other good thing about ZFS is it can really keep a lot of spindles busy. It's smart. It knows where that each disk exists. It's not hidden behind a virtualization layer like the LVM or a RAID layer. And so for metadata, localized operations may not necessarily cross all of the disks, right? If you have a simple, RAID 1+0 kind of setup. So there's a potential for speed up with ZFS. We don't know exactly because there's, drawbacks in terms of, it's because it's reliable and because it's doing checksumming, it has some overhead. It's doing multiple copies of the metadata, so it can do recovery. So there's, this potential for more overhead, or there is more overhead. How much that impacts the performance, we're not totally sure.
I want to add that during the CMD3 project that resulted in this new MDS implementation, one of the bottlenecks was journaling I/O for LDiskFS, and with ZFS this is no longer a problem because ZFS uses copy on write, so there is no need to journal metadata.
And anyone comment on the there's a benchmark that a number of our partners and customers have been talking about, which is loading up a metadata server with a large RAM disk and comparing that to the performance as a perhaps an indicator of what a large flash storage device would look like. And I'm wondering if you could just comment on kind of our interest in that benchmark.
We're interested in it. I don't know. I don't think anybody has actually done that test. I know for ext3 in general, people have always said, "Oh, I'm going to put the journal on a flash device or solid state disk or something like that," because the journal is seems very important. You're writing to it all the time, and it's small enough to be put on solid state disk. But the truth is that the journal is written almost linearly, and as a result, it's no faster when it's on its own solid-state device.
Actually, I believe I touched a little bit on this already. So at Oak Ridge, there was essentially a huge RAM disk that you connect to your MDS, and that was used as a MDS backend storage. And there was no big difference compared to DDN up to a certain point before you saturate the DDN cache completely. And that's also multiple gigabytes of basically RAM disk. And especially if you have a write-back cache in the DDN enabled, so that you see the benefit both on reads and writes, up to a certain point there is no benefit when you have smart RAID arrays that have huge caches. Of course, once if you have like just small disk caches or not smart controllers, then of course you will see pretty big performance boost from going with like a solid state that doesn't have a seek latency.
Okay, so it sounds like the jury is still out on this one. Next question.
Yesterday in the clustered metadata discussion, I didn't hear much mentioned. I know it's still well, I guess it's not necessarily in the design phases, it's kind of in the can.
So for clustered metadata, what is the design for adding another node to the cluster of metadata? That there's rebalancing required, it seems.
Actually, there is no some like one-step rebalancing, but when you add new MDS server to the cluster, new files, actually new directories will be ultimately created on this new node, and as a result, parts of namespace will be stored there. So it happens dynamically. And well, also the not yet implemented plan is to rebalance across new MDS nodes some critical databases like feed location database.
Okay. Next question.
I was wondering what areas of effort or concern do you guys have with clustered metadata interoperating and integrating with other features such as the write-back cache or size on MDS, which seem to affect many of the same areas quite directly?
Actually, with write-back interaction of clustered metadata with write-back cache is very interesting because this gives rise to completely new situation when your write-back cache contains a modification from multiple metadata servers and you have to integrate them, to reintegrate them transactionally. So we have some sort of distributed transactions, and there is some design underway for this. And I think it's quite exciting. It's very scalable and probably state of the art. And for size of on MDS, I think Vitaly will comment.
Well, regarding there are no many complications with clustered metadata because all the size of MDS attributes. If you because all the size of MDS attributes are stored on inode or an extended attribute right with inode, which is placed in one particular MDS, so other MDSs are not involved in it. So that's all.
Keep in mind, by the way, that the size on MDS code was actually implemented against the clustered metadata code base, and although size on MDS will be available in Lustre 2.0 sooner than we actually turn on clustered metadata, the underlying code base for 2.0 is the CMD code. We just need to do more work and to bake it a little bit longer so that it's fully recoverable and everything in clustered metadata mode.
Yeah. And just to add a little bit, I mean, the implementation of clustered metadata is really an enabler for things like write-back cache because it introduces all of the concepts like FIDs and having multiple places to look for metadata, right? And I mean, when you have write-back caching, essentially, I mean, you're getting like a little mini MDS on that client in some senses, and not in every sense. But you know, without clustered metadata, we couldn't do these other things.
Next question, please.
I was wondering if you have any issues or what kind of challenges you run into the fact that you guys are spread out over the world, speaking different native languages. How's that like? What's that like working together?
We just use IRC most time and email to discuss technical questions, and yeah.
Yeah, we pass the ball all alone between ourselves. That actually is a nice thing. So, for example, we have almost a 24 hours coverage for time regions at times when that's needed. And it works quite nicely, I think, at least. I like it. The only downside is sometimes it's needed, you need to stay a little bit longer during the day to meet somebody from the other side of the world, but that's tolerable.
Yes, that's what I was going to comment on. Sometimes arranging meetings between teams, sometimes it's hard because, for example, Atul is in Australia, I am in Portugal, and then we have people in the US and Canada. So due to all these different time zones, sometimes people have to stay pretty late, and sometimes it's hard, but it works well.
Yeah, some amusing anecdotes that can be added is sometimes, I mean, we have traditionally used IRC as a communication mechanism, and everybody that works with us is very fluent English typer, and we had asked Alex Jourelev to come to a conference years ago, and he didn't want to come because he said, "Oh, I can't understand English," right? And I'm like, "What do you mean? You're writing English to me right now," but you don't notice it because they type so well in English, but they may not have the ear or speaking English. It's hard to think of the words to pronounce and things. Of course, he's a very good English speaker. In fact, he's just being modest. But since we've started with Sun, we have more teleconference calls, and there are sometimes people dislike the conference calls because it's because of accent and things. It's harder to understand people than when you are typing at IRC and you don't have a permanent record of what was discussed and things like that. And I've on occasion had to provide English to English translation between the various peoples on the conference call, right? So there are some challenges, but I think the internet and the tools that we've settled upon have really facilitated a lot of that, and it's worked out very well.
Interestingly, I found also that especially in our earlier days as we were getting to know each other, the North American English ear is attuned to English spoken in a lot of different dialects, but especially when the Russians and the Chinese are speaking English to each other in the same room, it's harder to their ear is less accustomed to hearing English in the other dialect. I think another thing that kind of distinguishes our team, I think, from coming into Sun, which is a global company and has people distributed all over the place, is that our teams are not silos. We don't have a team working on one feature in North America and another team working on another feature in China. That our teams are truly distributed with people kind of all over the place. And although that certainly presents some challenges, one of the things that it also enriches our culture as a team, so that when we do come together in an event like this, these are not tribes of people who have been working on different features that are coming together. It's people that work together on features and solving customers' problems every single day. So I think that it also adds to our strength. Interesting question. And we do get together a couple of times a year and do social things and engineering planning things. So we do get a good amount of face-to-face time a couple of times a year. Good question. Next, any other questions, please?
We've talked about a lot of exciting new features, and of course we want them all, and we want them now. But each one of these seems to add a kind of a scary level of complexity to an already complex system. And so I know you've done some things like rewriting the client I/O to go back and say, okay, it's time we've accreted all these new things. It's time to rewrite it, layer it, establish new layers. What is the next thing that is in line to be reworked because of all these added features?
Well, we probably all have things to say about what the next things are. And the networking recovery side, in 1.8, we're adding adaptive timeouts. It's probably the biggest feature there, and I think could really be a big benefit for the larger clusters. As you know, instead of having really long default timeouts of 10 minutes, we can hopefully have a much shorter general timeout case of a few seconds, and then when load spikes, it will adapt itself to be a larger timeout as needed, and then go back to a normal size. In another feature that will help on the recovery side is version-based recovery also scheduled for 1.8. Actually, adaptive timeouts is in 1.6.5, but disabled by default. But if someone wants to try it, then it is there to use. Version-based recovery will be in 1.8, and that will, again, for larger clusters where clients just aren't necessarily always there to do the recovery when a failover occurs, then it should help the rest of the cluster just to recover normally.
So what I'm asking is there an area that needs to be basically rewritten from the ground up? I mean, what is the next area that needs that work?
One such area is an attempt to improve portability of our code, and in the course of few last years, the situation here greatly improved already. We get rid of VFS dependencies on server, and we isolated dependency of VFS and VM in a client, so that we now can rewrite only some arguably well-defined pieces of code to port our client to a new platform. And also an effort is underway to complete and clean up our low-level portability library, libcfs, that provides primitives for memory allocation, synchronization, some basic things like that is used. Yes, and that will make it simpler to port our code to other platforms.
So one area that I know is near and dear to Eric Barton's heart is rewriting the Portal RPC code. It's been around since day one, basically, and there's even recovery itself was added in, after the fact, and it's not that it's horrible per se, but it could use streamlining, because we've come a long way in terms of going from serial RPCs to batches of parallel RPCs and getting a single mechanism to do that. We have different versions of RPC requests over the wire, and there's code added in, and a few layers of, well, let's write a generic helper function and not change all of the call sites. So we have, for even just allocating a request, we go through 3 or 4 wrapper functions until we get to the real function that does something. And so there's a bunch of areas. One of the silly things is all of the code is, we have requests and replies, and everywhere it's REQ and REP, and that has actually caused bugs in our code because rec and rep look a lot the same, and so that's a silly and easy to fix thing that we need to do. But it touches like every single line of code in the RPC layer.
And what about the distributed lock manager?
Yeah, in distributed lock managers, there's one component which implements F locks, POSIX locks, and so on. This is doomed to be rewritten, and actually there are running jokes that Russians like to rewrite everything from scratch. We already have MTS and client being rewritten, and everything else is doomed as well.
Well, actually, another component is Lustre loading, which is currently rewritten. Besides the fact it hasn't been too well structured, SysMDS put some new requirements for it, because it needs to be done for OST service, but it only has been working on MDS for now.
So the moral of the story is that engineers really like to rewrite things, and if we had all the time that we could, we would love to rewrite a lot of the components. But we also have to keep the product up and running, and minimize changes. Next question, please.
So you said that you tried getting the product Lustre into kernel.org and they rejected. You want to describe that a little bit?
Can you repeat the question, please?
The question was, we tried to get Lustre into kernel.org and it was rejected.
Yeah, that's true. We got some suggestions on how we got basically two kinds of responses. One kind was like, your code and your modifications are complete crap, so you just don't come near us. Don't let us touch you at all. And we got a little bit of useful responses on how we might try to restructure our changes so that they might be accepted. But we never got to it. But this is still under consideration, and maybe someday this will happen. But so far, we were rejected on both technical and non-technical reasons.
Now, there were a lot of things that we have got in. I'm thinking, could maybe Andreas comment on what ext4 is?
Yeah, well, there's two areas that deserve mentioning. One is that, I mean, when we started, years ago with 2.4 kernels, we had a lot of patches, and in the 2.6 kernel, early on, there's already changes going in from Lustre, even though they're not called the Lustre changes, but NFS, for instance, is using intent operations, and CIFS is using intent operations in the kernel, but only for open, right? And so Lustre was using it for these other operations. We had raw operations that NFS could use to improve its efficiency, but some of these changes have gone in slowly. As of 2.6.16, you can run a Lustre client without patching the kernel at all, right? And so we have gotten a lot of our changes in slowly. Lustre as a module, either the client wouldn't be too hard because it just uses all of the VFS API as it exists today. We would just plunk it in as a module. It wouldn't be too bad. The server still has patches, and some of the patches we admit, are objectionable because of the way they bypass the VFS. Some of it, the reason it hasn't gone in is because even though what we've done is itself good, the way the kernel works is that they say, great, what you've done looks reasonable, now make every other file system in the kernel use this mechanism, or instead of putting this functionality, like we do direct IO with, zero copy, through the whole file system stack, they say, okay, well, actually this shouldn't really belong inside, ext3 or ext4. This should actually be functionality that belongs in the VFS. And so then they put this huge extra burden on our team to change the core kernel to do the right thing, as opposed to doing it in a local area where we can benefit from it, but maybe not all of the other file systems benefit from it. And for CFS at least, that would basically require rewriting a lot of our code to interoperate with this new VFS. We'd have to rewrite the VFS. We'd have to show that it works with at least one or two other file systems, because they say, there's another camp that says, well, you can't change the VFS just for your file system, right? So you have to show that it works with XFS or something else, right? And so the man years needed to do that is very high because we have such a complex product. For things like ext4, ext3, we did have a lot of patches that changed the disk format, but ext4, which is in kernels, I think starting 2.6.22 was the first kernel that forked ext3, and now there's ext4 file system, and it has a lot of our changes that have gone in virtually identically to what we have now. There's the extents format, multi-block allocator, large inodes, the fast attributes, nanosecond timestamps, a lot of our, all of the corresponding fixes in E2FS progs have gone in. So while I said 2622 was the first kernel that started ext4, you want to probably wait till 2625 is the first one that's really usable with straight ext4. And so that's a collaborative effort between, you know, CFS/Sun now and IBM, Bull in France, and NEC in Japan. They've taken, to be honest, a lot of the burden from us, you know, chasing the kernel to update our patches all of the time and integrate it and, you know, fight the battles with the kernel.org people to get this code in, because they see the value of, you know, all of the performance improvements we've done. I mean, the graphs show it. You know, ext3 was, whatever it was, 50 megabytes a second, and LDiskFS was 2 gigabytes a second, right? So they can see that there's benefit there, but while we had all of that benefit inside of Lustre, they want to see it for everybody. And so they've taken a lot of our code and fought the battle to get it into the kernel.
So, and yes, was another common argument against our patches, that nobody else uses it, so why should we include it for Lustre? And Lustre isn't even part of Linux kernel, so let's include Lustre into kernel, or do something like this.
Like the RAID 5 patches, right?
Yeah, and another thing I wanted to add is that our switch to patchless client doesn't mean that a lot of our interfaces actually got merged, like Andreas implies. Yes, some similar mechanism for some things, like intents for open, got included, but still we worked around things a little bit differently. And if we have API changes like what we had in kernel patches, the performance will still improve. It's just that with our other workarounds, we just brought the performance of patchless clients to the level of patched clients before those improvements.
Yeah, so Oleg just let you in on a little secret that we keep, and that is that metadata could actually go faster if we still patched the client, but you didn't notice because we kind of did it at the same time that that we made the clients patchless. Other questions?
So if you got most of the changes in for ext4, why not support it?
Because none of our customers are running any kernel that has ext4 in it. The truth is that, so 2622 is the very first version when ext3 was forked into ext4, and so it had the basic functionality. It had extents and a few things. MBALEC, I don't know if 2625 is out yet, but that'll be the first release that has MBALEC. And in order to access, like Lustre, because we talk directly to the file system, Lustre can access the MBALEC functionality and extents directly from inside the OST code. But for user space applications, there's this extra thing called delayed allocation, which is only useful from user space, because, you know, our Lustre clients, we already do delayed allocation and large I/O submission. And so Alex Jourev has written delayed allocation in order to facilitate MBALEC going into the kernel. And it needs a fair amount of testing because we didn't actually use that code ourselves, right? It was just written as a facilitator. And so when there's a vendor kernel that, you know, customers are starting to use, maybe Red Hat 6 or SLES 11 or what have you, that gets up to, you know, 2624 or 2625, then we can start throwing away our patches. But as it stands right now, the newest vanilla kernel we support on clients is 2622. And the effort of porting our patches over to ext4 is not really worthwhile on that kernel on the server, because there are lots of defects still in ext4 and lack of functionality. So we couldn't just say, well, they have MBALEC, we don't need our MBALEC. We don't, you know, they have extents, we don't need our extents, because the code that went in there is not exactly the same as what we had. And in the sense of, you know, some functions are missing and things. So we would still need to make patches against it, and it's maybe 2625, we can remove 90% of our patches.
But have you looked at that as a mechanism instead of ZFS? I mean, does it support all the underlying structures that you would need instead of Extended 3? Because I mean, you could always maintain your own copy of it until it becomes wider spread.
Well, I mean, there's two things. One is the work effort, right, to move from ext3, because all our patches already exist on ext3. So essentially, ext3 plus our patches is 95% of what ext4 is, anyways. So in that sense, it's yeah.
You want to do the work, it's open source. Go ahead.
Yeah, no, but the other thing is there are still limitations in ext3. You still have static inode tables, right? You know, we were looking at like checksumming and all of these good things. We had started on adding checksums into ext3, journal checksums. We have group descriptor checksums. Those are in ext4 and in LDiskFS. But there's still all of this other part of the data and the metadata that isn't going to be checksummed. There's, you know, the static inode tables. There's inode limits. There's the size limitations, even the extent format itself. You know, only 16 terabyte files, and you know, whatever it is, 4 exabytes or something. It's 48 bits plus, you know, times the block size. So we can get like 2 to the 62 byte file systems, which is pretty good with ext4. But then you still have to FS check it, right? I mean, which isn't to say that you'll never have to do that with ZFS, but the whole setup of ZFS, the resilvering, everything is ready designed to happen online, right? So snapshots, all of those things are pushing us towards having a more sophisticated file system.
When we looked at the effort of implementing the kinds of features a lot of our customers were asking for on top of LDiskFS, that includes kind of a more robust and modern implementation of RAID, really good performance snapshots, checksumming, you know, all of the things that Andreas was enumerating there. You know, our wild calculation was something from 10 to 24 person years worth of effort. And there wasn't a lot of support from the ext3 community to kind of contribute to that. So it really came down to a very simple decision, and that was to create the kind of industrial strength underlying file system that we needed. Was just incremental work on top of ZFS as opposed to trying to do that all on ext3.
And
we have
one.
Go ahead, and I'll poll also for networking questions. I'm interested in hearing any networking questions in our last few minutes.
So one tiny comment is that the decision to go to ZFS was actually done before we talked to Sun, right? That was a decision that CFS had made, and it was actually, I mean, my thought at least, it was one of the contributing reasons why Sun wanted to acquire CFS was because we had, you know, made this commitment to go to ZFS because we picked it as a, you know, the best file system, and you know, the DMU actually matches directly with how the OSD API that we had come up, you know, even on top of ext3 before we even looked at ZFS. So the match was very good, right? And so it's not an issue of, you know, we got acquired by Sun and, oh, well, we're forced to use ZFS. I mean, it was exactly the opposite.
Okay, we have time for maybe 1 or 2 more questions. Anyone want to ask a networking question? Networking question? Any networking questions? Oh, Isaac's going to get off easy. Okay.
Well, we've just been discussing the difficulty of integrating with other code bases, which I understand is a significant source of difficulty for you guys. But one of the things that I would like to ask about is not so much the code, but the build system for Lustre. Because I know our release engineer at PsyCortex has probably grumbled more about Lustre builds than anything else. The patches, the back and forth with OFED, the LDiskFS renaming, the strange use of automake. And from talking to other people here, we're not alone. I've heard a lot of other people raise similar issues. So is there any specific effort underway in the next couple of releases to make that more tractable, especially as we continue to add features that are going to make this even more complex?
So as a bit of historical background, the crazy use of automake was, you know, entirely based on the fact that we had to build against the 2.4 kernel and the 2.6 kernel. And so that's no longer a requirement. You know, I don't think there's anybody inside the Lustre group that actually likes the build system. But at the same time, there's honestly nobody that really understands it anymore either. So yeah, you know, Ricardo, I mean, has used in the ZFS and the ZFS Fuse development, he's used SCONS, which is actually the Sun, you know, configuration system. You know, I can't say that. Anyways, that's the system that Sun uses for ZFS. No? No? Okay. Anyways. Okay. So Ricardo knows something about build systems, and he's probably the only one who does in our company. So maybe we're going to go to that. And so the ZFS subtree in the UOSS and the UMDS branch is actually using SCONS because that's what we pulled over from Fuse. And so that may, you know, migrate through the code. We're also changing probably our source code control system from CVS, and that may facilitate some of these, like the patch application and things, because Git and Mercurial have more facilities for keeping patches in line with you know, changing code branches. We don't know yet.
Still considering.
So the comment from Peter Jones was that we're going to make it easier to integrate with OFED in 1.6.5, right? Okay. Okay, so let Peter Jones know about your pain points. He will fix them for you. Are we working on adding what to OFED? Are we adding Lustre to OFED? Are we adding LNet or Lustre to OFED? Not. Do you want to comment?
I don't think so.
Not that I've heard of. Anyways, let's wrap up there. I encourage you. These guys are going to be around. They're not going to disappear right away. You'll bring any questions that you'd like to ask up and mingle a bit. I'm not sure, Kevin. Any closing comments that you would like to make? I'll turn this over to Kevin, but I just want to thank the engineering team and give them a hand of applause for standing up here and talking to us today.
Thank you, everyone. You've made this a great couple days. We really appreciate the time and effort and the travel time that you took to come out and join us. We hope it was rewarding for you as well. We talked yesterday a little bit about training, and there was quite a bit of interest. So we're going to have a couple emails after this conference come out to you requesting your interest about training, and do you want level 1, level 2, and where you're located at. If you could respond back to that, we're going to try to act on that pretty quickly. We'll also be updating on the status of the presentations and the webcam uploads on that as well this week. And then finally, we'll probably also send out just a small little survey of this event. It's the first time we've done it on our Sun, and we have some ideas about doing it next year, and we'd like to get your feedback on it. So that would be a very valuable thing to get back from you. So with that, I just want to thank you again very much. I also want to thank Karen Lee and Zheng Yuan for putting on this event for all of us. They put a lot of hard work and spent many weekends over the last few weeks putting this together, and it was very much appreciated, so thank you. So safe travels, and we'll see you at the next HPC or Lustre user group. Take care.